Alright class, I'm homesick, but I'm going to go ahead and walk you through this sheet of notes. So you should already have one of these sheets. If not, make sure you grab one real quick and then show the video. Follow along in the notes, and then the assignment will be the back side of the sheet. So you'll see this first section is called synthetic substitution. It doesn't give you any instructions, so I'll provide that here. It's just like when we did synthetic division. So what we're going to try to do is we're going to find f of negative 3. Previously, we've done what we call direct substitution. You plugged it in. You do 3 times negative 3 to the fourth minus 3 times negative 3 to the third, etc. You can do that. It's called direct substitution. But synthetic substitution is actually simpler. It's faster. So with with synthetic division, before, you may remember we had the box. The number that's going to go in the box is the number you're trying to plug in. We're trying to evaluate for negative 3. So just put negative 3 in the box. And then, just like synthetic division, list our coefficients in order. So look at the degrees. The largest one is 4. It goes 4, 3, 2, 1, 0. So we have all of them. So the coefficients then were 3, negative 3, 4, 5, negative 1. Every term is represented. There was a fourth degree, a third degree, a second degree, a first degree, and a 0 degree. So we have them all. We don't have to put any zeros in. And then hopefully you remember how to do synthetic division. Drop the first number straight down below the line. And then as soon as you get a number below the line, you multiply it by the number in the box. So 3 times negative 3 is negative 9. We write that in the next spot, below the next coefficient, then add those together. Negative 3 and negative 9 add to negative 12. So we got it below the line, multiplied by the number in the box. Negative 3 times negative 12 is positive 36. Add it to 4, we get 40. Gonna get a pretty big answer on this one, that's okay. 40 times negative 3 is negative 120. Add 5 to that, it's negative 115. Multiply that by negative 3, we get a positive 345. Subtract 1 from that, 344. So that's our answer. That's what f of negative 3 is. F of negative 3 is 344. We don't actually have to plug it in and solve. So let's do one more. Number 2, we're finding g of 2. So you can put a 2 in your box. Notice it starts with a degree of 4. Degree of 3 is negative 2. Then it skips some terms. There's a 4, a 3. There is no x squared. So it's a 0x squared. We have to use the 0. So 4, 3, 2, 1. So x to the first. There's none of those either, so there's the 0 of that also. So x to the fourth, x to the third, x to the second, x, and then should be our constant, that's the 3. So make sure you get those zeros. If you don't get the zeros, we're not going to get the right answer. So drop the first number straight down. 3 times 2 is 6. Negative 2 plus 6 is 4. 4 times 2 is 8. 0 plus 8 is 8. 8 times 2 is 16. 0 plus 16 is 16. 2 times 16 is 32. And 32 plus 3 is 35. So only the remainder, the remainder is the part I care about. That's what g of 2 is. When it was synthetic division, I cared about all of those coefficients. But all I want to know is what g of 2 is, and so that's 35. Just the remainder. Okay. So now we get into, it's called the factor theorem. I'm not too worried about what the factor theorem says. But if we jump down to like number 3, we're told that x minus 2 is a factor. It's a factor of this. And we're trying to factor this all the way. We don't know how to factor this all the way, but I'm giving you a clue by telling you one of the factors. So what we need to do is divide this factor out of here, and then we'll try to factor what's left. When we do our division, we're going to do synthetic division. And if a remainder is 0, then it was a factor. That's what this factor theorem says. If your remainder is 0, you know it was a factor. So, synthetic division, our coefficients. We have 1x cubed, negative 7 x squareds, 4 x's, and 12 for a constant. In the box, we have this factor of x minus 2. What we need to remember is that if we have x minus 2, if we solve it, if we set that equal to 0, we'd have to add the 2 over, and you'd have x is a positive 2. That's what goes in the box. We have to do the opposite of what's in the factor. So because it says x minus 2, we have to put a positive there. Now we do synthetic division. I better get a remainder of 0. That's what tells me this was a factor. We'll find out. Drop our 1 down. 1 times 2 is 2. Negative 7 plus 2 is negative 5. Negative 5 times 2 is negative 10. Negative 10 plus 4 is negative 6. Times 2 is negative 12. Plus 12 is 0. So we did get a remainder of 0. That's what was supposed to happen. So at this point, we had this. We factored out x minus 2. By dividing by the 2 there, we actually factored out x minus 2. So I'm going to write that down. I haven't lost it. I just divided it out. I factored it out. Now in the parentheses, what's left? We have 1, negative 5, and negative 6. 1 what? Well, remember, if this is x to the third, this 1 is going to be 1x squared. And then descend from there. This is the x, so negative 5x. And then a constant, negative 6. And so we're supposed to try to find the remaining factors. So this, what I have left, should factor. This is what the type of factorings we did in chapter 4. So we have the x minus 2. Looking for numbers which multiply to negative 6 that add to negative 5. That would be a positive 1 and a negative 6. 1 times negative 6 is negative 6. Add them together, you get negative 5. So we factored it all the way down now. The next step will be tomorrow, where we will turn around and graph this. It's helpful to know the factor so that we can graph it, but we're taking it one step at a time. So if we know one factor, we divide it out, factor the rest. That's what we're going to do on numbers 4 and 5 both. So we have a factor of x plus 1, so I'm doing minus 1 in my box. 1x cubed, 1x squared, negative 16x's, and negative 16 for a constant. 1 times negative 1, add those together, we get 0. Times 0 is 0, negative 16 plus 0 is negative 16, negative 1 times negative 16 is positive 16, add those together, I get 0. So my remainder is 0, that's what should happen, that's what this section's about. So at this point I just factored out x plus 1. What am I left with? 1. Well, that was x cubed, so this is x squared, so 1x squared. Plus 0 x's. If it's 0 x's, I don't really have to write it. You can, and it actually might be helpful in terms of factoring, in case you don't remember your difference of squares. If you want to write the 0, you can. And then minus 16, and then I have to try to factor that. So I'm looking for two numbers that multiply to negative 16 that add to 0. That would have to be a positive 4 and a negative 4. If they multiply to negative 16, they add to 0. Alright, now number 5. Factor of x minus 1, so I put a positive 1 in the box. We have 3x cubes, 10x squareds, negative 1x's, negative 12 for a constant. Drop the first number straight down. 3 times 1 is 3. Add those, we get 13. Times 1 is 13. Subtract 1 from 13, we get 12. 12 times 1 is 12. Add to negative 12, we get 0. So it got a remainder of 0. It was a factor. X minus 1 was a factor. So we pulled it out. What's left? Oh, we have 3. There was x cubed, so this is x squared, so 3x squared plus 13x plus 12. Now I have to factor that. We have a lead coefficient this time, so I'm going to switch over to a pencil because I don't know if I'm going to get it right the first guess. Sorry, it took me a second to find a pencil with lead in it. Okay, so the 3, to multiply to 3, we have to have a 1 and a 3. To get to 12, we could have a few options. 1 times 12, 2 times 6, or 3 times 4. So we're going to start trying some options. We know we've got this x minus 1 out front. That already has to be the case. I'm going to have a 1x and a 3x to lead the way. Let's try 3 and 4 first of all. Okay, those get multiplied together. 3 times 3x is 9x. Multiply these outside. Whoops. X times 4 is 4x. I'm trying to get those to combine together to make a positive 13. Oh, well, 9 plus 4 is 13. If they're both positives, we get a positive 13. And we didn't talk about this, but that last sign was a positive. In order for things to multiply to a positive 12, they have to have the same sign. So a positive positive would work. So that's right. So I want this 3 then to be positive. I want the 4 to be positive. And there's my answer. I might rewrite it now in my pen. But I have an x minus 1. There's an x plus 3. And there's a 3x plus 4. Alright, so that's the end of the notes. I'm going to flip this over to the back page, point out a couple of things to you. On 1 and 2, this is where you do that synthetic substitution like we did in the first two problems. I'm asking you to do two things, though. Find f of negative 5 and find f of 2. So remember on this one, you're going to put negative 5 in the box for synthetic subdivision, and you're going to put 2 in the box, and go ahead and do the problems to find, and you only want the remainder. The remainder is your answer. That's what you'll do for 1 and 2. 3, 4, 5, they're like the last problems I just did. Oh, except I realized I missed part of number 5. So I forgot to tell you what the factor is. Give me just a moment. I got to look it up. I don't have it off the top of my head. Okay, so for 2x cubed plus 7x squared minus 53x minus 28, I'm telling you that there's a factor of x minus 4. Okay, so in each of these 3 problems, this is the factor. So you're going to do your synthetic division. So since that's a plus 2, you're going to do your minus 2 there, and then do your 1. Oh, there's no x squared, so it's a 0. Your x is a negative 3. Your constant is a 2. And so you're going to do synthetic division with that. So that's how these work. They're formatted just a little different than the ones on the other problem, because after the semicolon, that's where it tells you the factor. So factor that out and then see what's left and try and factor. And then on the very bottom of the page is just a little bit of review. Number 6 and 7, there are a couple factoring problems from last section. So I want you to practice that again as well. All right, good luck.